Hi everyone, welcome back to Gratuitous Math. So today we'll be going over systems of equations. This has been a really requested video and it's something that I have to explain to students very often since this can be a pretty confusing topic, especially with some of the more difficult methods. But once you figure out how to recognize the things that you're looking for and you understand how to think about a systems of equations and exactly what it is we're looking for, it becomes a little bit less complicated and a lot more straightforward. Okay, so a systems of equations is when you have more than one equation, and we're really focusing on the high school level of systems of equations, so not any upper level things that you would need matrices or any linear algebra to do, really just the basics. So for our purposes, we're always looking at a system of two equations so that we're working with two variables. And we're looking for where those equations are equal. So when we talk about the solution to a systems of equations, we're looking for the point of intersection. So let's put that in there. So the point of intersection. And when we're talking about a point of intersection, you might be thinking, well, intersection of what? We're dealing with two linear equations. So you would have, if I was to sketch a quick little graph here, so you have your x and your y, you would have your line 1, and you would have your line 2, and they intersect at this point. So at this particular point, the x and the y value for both of these lines is exactly the same. They are equal at this point and only at this point. So the solution to a system of equations, the thing that we're looking for is this point. It's a coordinate. So since this solution is a coordinate, that means that it has two components. So it has an x and a y component, which is something that's important because sometimes students will find one and then they'll forget that they have to go back and find the other. So you're really looking for the coordinate of the intersection point. So the first method is the most straightforward method. It's called comparison. So this is the method that you use when our two equations are both in the form of y equals ax plus b. You may have seen this written as y equals mx plus b. They mean the same thing. A or m is your slope. So whichever version of the equation you're comfortable with, that's what you should use. So here, let me just number our steps. 1, 2, 3, 4. So we're going to start by making the ax plus b parts equal to each other. So everything on the right-hand side of that equal sign, we're going to make those two things equal to each other. So here, I'm going to make 4x minus 9 equal to x minus 3. Okay, so step 1. Step 2, we're going to solve for x. So we want to move all of our x's over to one side and all of our numbers to the other side. So on this side, I'm going to have to subtract an x on both sides. That will give me 3x. And here to get rid of that minus 9, I'm going to need to add 9 to both sides. And that will give me an x equals 6. Or 3x, sorry. To get rid of that 3, we will need to divide by 3. We'll get x equals 2. Now we need to go back and find y. So at this point, we've done step 2. So step 3, plug the value of x back into either one of the original equations to solve for y. So here, when it says either one, this is because either this equation will work and this equation will also work. The reason why both of these work, and I'll go back up to our picture, is, well, first of all, when we made these two things equal to each other, we found that we get an x value of 2, which means if I go back to this picture here and zoom in, if we imagine that these are the two lines that we're currently finding the intersection point of, this x value would be 2. This is the x value of this intersection point. So at x equals 2, I will be getting the same y value for both the purple line and for the green line. It doesn't really matter which equation I put it in because I'm using the value of x equals 2. These two lines will only be giving me the same y value at this particular x value. So now we'll go back and I'm going to pick the second equation since that one is a little bit easier to work with. I don't have to do any multiplying. So y equals x minus 3. In this case, my x is 2. And my answer is minus 1. So that was my third step. I solved for y. And you cannot forget your fourth step. Write out your solution as a coordinate. So, or you could use a sentence for word problems. Up to this point, we've just done a bunch of math, but we actually haven't given an answer to our problem of, well, what is the solution to the system of equations? All of this work is meaningless if you don't actually give an answer. So your answer should be in the form of a coordinate since that is the solution of the systems of equations. So you're going to have 4 is your x, 2 is your x value, -1 is your y value. Okay.